guess we can start. So we have some main thing first, talk about our research projects. So I think now the actual period is almost over. So I think it's good to talk about that. And given we have like 40 something in this class and 70 students in the other class. So I think it's okay to allow up to 6 members in a group, okay? Or you can do it individually, there's no problem. Up to 6, okay? And if you have more than 6, then you have to let me know. To convince me you need more than 6, okay? Assume 6 or below, okay? And the day that submit will be the very last day of the semester, okay? And this is also the day that we will have a test on that day, okay? I think probably 4 to 6. We'll pick an hour, probably we'll book the room like 4:40 to 6:30, 6:15. Then probably we just maybe start at 4:55 and stop at 5:55. But here we will email you to see whether you can attend or not. If you have legitimate reason that you can't attend, then we will schedule another makeup after that. But remote, I mean, unless majority of you cannot do it, but we'll do it on that day. But otherwise, if you have legitimate reason that conflict with other thing, or you have suddenly got sick or some more reason, then we will schedule the makeup together. Okay, so the makeup time will not tell you, but we will tell you when things settle down. It depends on how many of you actually do it, but most of it take it's just an hour, so it's like at that time. So but the TA will ask you, and then we schedule, and the exam is just open book, open note, everything is open. But not I guess we can't open the your iPad or computer device because of there's some cheating concern. So you can bring infinite number as many pages as you want, but we cannot allow electronic device. You can have calculator, that's fine, but no use of electronic equipment. Okay. I mean, it's kind of outdated, but I mean, still we have no way to jam your signal. So I'm sorry. Probably it's not. I mean, but if you can convince me that is no cheating concern, I don't mind. I mean, you can tell me what other classes doing. If they open both, they allow computer, let me know. Then we can try to accommodate. Okay, it's not my concern, but I just don't want it to be. I mean, you take another test again, right? For the test, and then because you can do one-person team, so I assume that there's no free riding. Okay, if there's free riding, I'm not entertaining that thing. You just handle it by yourself. Okay. If you form a group, then make sure that your group may actually do the work. Okay, I'll talk about example what kind of group project that can be done. Okay, and the page limit will be proportional to how many group members do you have in a group. If you have you're doing one person, that's 1 A4 paper both sides. If 2 person, 2 A4 paper both sides, and 3 person, then same, so on and so forth, right? Up to 6 will be 12 pages, right? And you write a concise report. You can imagine this business standard, right? Imagine I'm your boss or I'm your client. You have to convince me as quickly as possible, right? Not to spend writing a long thing, right? Try to use more graphical idea, okay? And so probably I mean, depends on time, right? Because we might be doing some Python or R at the end. If you have time left, then you know how we can make a better graph. But that would be if I can't do it, you go to data camp, right? But I guess this year we should have some time to cover some more advanced software. I mean, of course, that would be optional, not in the text, but they will be useful for your group project. Okay. Sorry. Sorry. Yeah, we will cover some Python or R. At the end, if we cover everything, we'll do that. I mean, I think this year we cover slightly faster, so we can do it. But this year we have some problem of a lot of holiday canceling here and there, so I'm not entirely sure. But they will optional anyway. So if it doesn't work, we'll figure out some way to make it work. Okay, we cover, but don't worry, the Python or R will not be appear in the test or assignment. That will be optional. Will be good for your project, so you don't have to worry about that. I think I'll cover Python. That would be my thinking, but I can also do R. Doesn't really matter anyway, because if you know it, they will be very similar. Okay, but at the worst case, you can go to data chem and work out. I mean, that would be fine. Okay. Just make sure everything you do it in a PDF format. Your report should be in the PDF format, and submit to the worry guy when you need it. And the way I suggest is you, as I said, you describe your data first and tell us what kind of the main question you're trying to answer. Right. Later you see some example. I'll talk about them, that you see how they're being done. Okay. And this appendix, you can put as many things there, but of course don't put too much stuff, right? Because I mean, usually I don't read unless I have some question from your main report, right? The same as you can imagine the same as I expect you send your report to your client or your boss, right? They only read it when they really think that I need something more, right? Don't expect me to read the appendix, okay? I only read it when I need it, but you have to provide me, right? Also the code and the data, I mean, you also want to ship the file and there, okay? So that would be the idea, okay? To give you a better understanding, maybe, I mean, as I promised, I have uploaded some examples. So these are the example, not last year, but I mean, I didn't put last year, but do the same. The only difference is, I think, is like in the 2000, because of COVID and also various reasons, the page limit is 1 page per person. Okay, now we have 2 pages per person, but I used to have 1 page per person because of the, that is, I think is the earlier one. So this one, this project done by 3-member group, you have three pages, but because at that time it's 1 page per person, but now you have 2 pages per person. And the question is asking whether the zodiac sign is going to change your behavior. So that's a research question. Okay. And it outlines the methodology, right? And then tell you what kind of sample they're doing, right? The data description, and tell you further refining data, tell you what are the method they're using, what are the limitations, the research question, and the analysis. Right, it's very clear how this screen present. So you can imagine that among the sample I uploaded, right, is B+ or above. I mean, given the good word I give, then you can imagine what kind of grade I gave, but I cannot tell you what grade, but you can see what kind of grade they might be getting, right? That is the thing. It's already on the dashboard. If you want to study, you can study. Okay. And the other one, something study like I just randomly pick. This is a 5-member group, so you can see 5 pages, because I said at that time it's like 1 page per member, but now allow a little bit more, because I guess that a little bit allow you to run a little bit more. So this one studying whether actual grade and the perceived grade, how they're different, because Hong Kong have a college entrance exam called DSME, and see how the actual grade and they're different. And this is the model, and you do several analysis, do some scatter plot, calculate some data, some summary statistics, and do some text, and do further analysis. Okay, so there's some conclusion here. So there's some idea that what thing you can do. You can see it's not limited to economics. Anything or business setting, anything that you think that you worth doing, you can do it. Okay, I mean, I don't limit to business, but of course you are advised to remain in business because you are a business major, but it's okay you do like these two is not directly with the business. It's fine, depending on your interest. I mean, I don't judge based on whether I like the topic, but at least I think the topic is interesting. These are interesting topics, right? So, is that clear? Is that clear what you're going to do? Just 2 pages. You can. It's not a lot, right? I mean, 1 person per person, 2 pages. It's not asking not a lot. Is there any question before we proceed? I hope there's no problem. Because we don't have midterm, so this class it just only have this and final and some assignment. So it's not. I hope that's not too heavy loaded. Even though we have 4 credit class, right? It's not 3 credit class, 4 credit class. So you should expect 1/3 more than the other course, but I don't think the workload is a lot. So you should be able to find this thing manageable. Because this class is heavy, so in some sense it's a little bit more heavier in terms of content, but I think the workload wise is not something too heavy for you. Is there any question before we go on? This is the okay. For those who arrived late, I have announced 2 admin things. One is the exam, as I said, will be on the very last day of the semester, which the TA will send you the form, Google form, to let me know the availability on that day. If you have legitimate reason to absent from that, let me know. Then we can reschedule you with other makeup. Okay. And the second thing will be the projects, which I give you more detail in the sample there. I discussed a little bit. In case you still have a question, you can ask me or TA. But I guess with all the sample, I don't see any problem, because in the past 3 years experience, I don't see any problem with the project. No people have problem and no one complain. Because you can do your own work. It's 2 pages, so what can you complain about, right? Having homework sometimes maybe even more workload than this one. At least this one I think is interesting. You can self-collect your product data. Some people go to the library and ask data, or put it on your Facebook or Instagram to ask questions. That's also fine. Or you can just use data from a public, or from data from other people collected. Totally fine, no problem. Okay. Is there any question? Okay. And if not, then we would probably able to finish this probability for this class. Okay. And then probably we will release the assignment later. Okay. Maybe over the weekend. I'll work with the TA to make sure that the homework is more manageable. This year we will reduce the homework a little bit so that you can spend more time on the project. So I'll work with TA to fine-tune the assignment. But the assignment you expect will be similar to the examples you do in the class. Okay, slightly more, but very similar. Okay, just a very quick review of what probability means, because that is what we're doing. And after this next class, we will go on to talk about more advanced probability, is the random variable. Okay, but that will be, we focus on the basic definition of random probability, right? The probability is defined as long run frequency. There's a classical thing, right? That's how you should understand that, right? How this connect with our real world, right? Is suppose you have a experiment, you can repeat many times. What is the percentage or fraction of the outcome that is favorable to what you want to measure as a numerator, and the denominator will be total number of experiments you are doing, right? Imagine that you roll a die 6 million times, right? 1 million times will be for each of the number, right? So if the die is fair, right? So that's why you would say the probability of having a particular number is 1/6, right? The reason is being that that is the relative frequency that actually you repeat the experiment, right? That is defined exactly from the real world, right? There's some experiment or from the data that is tell us what's probability, right? Because that the idea is trying to see is relatively which one is more likely, right? To quantify the idea that I don't know the future, but I have a saying that which one is more likely to happen, and to quantify that statement, that is the idea of probability, right? And this rely on the real world, but we really want to abstract from the idea of the real world, right? We don't want to do experiment. That's the reason why we talk about this axiomatic foundation, right? We, instead of talking about The relative frequency, we don't rely on that. We don't rely on real world. We define something, we make the minimal assumption. That's mathematics, right? We make minimal assumption and we derive the rule or property based on this assumption, right? Just to remind you what assumption we use. Right? The first one is very simple. The probability must be 0 to 1, which is trivial, right? Second one is also trivial, but do have some meaning, is the probability of sample space is 1, which means that we know all possible outcomes that may realize, which is there's no unimagined outcome that realize, right? Just remember the example I give is like, it's not a magician, right? You toss a coin, it must either head or tail. It cannot be a rabbit comes out, right? So that is the idea, right? So you know it. Either if you know that a rabbit comes out, that will be one or should be part of your sample space, right? You should be complete description of what's going to happen. And the last one is probably the major one, and that is actually the main bite of probability theory, which is saying that if events are mutually exclusive, okay, or you can imagine more fundamentally, there's a different outcomes, and these outcomes are mutually exclusive. Remember what's mutually exclusive, which means that if one happens, the other doesn't, right? It just rule out the idea that they can happen to be true at the same time. And in that case, the probability of them will be sum of the probability, okay? You just can evaluate one by one. As long as they're mutually exclusive, you can look at things one by one. That's the main idea. And add them up. Okay, let me repeat the statement. This is important because it means if things are mutually exclusive, okay, and you look at the union of this, right? Either this or that, and there's no end, right? And in that case, you can look at one thing and the other, you calculate probability for one and the other, add together, then we're done. Okay? We don't need to separate. And this will make a lot of sense, right? Especially when things are finite, right? If the outcomes are finite, it's normal, right? It's 1 + 1 + 2. That's no problem, right? Because they're disjoint, right? But the problem lies on, technically, if you learn math, that will be infinite number of them add together. Is it going to be bigger or smaller? We don't really know, right? It can be smaller, right? Can be bigger. Because go to infinity, things can be complicated. But well, they write down here, but they allow n to be infinity, right? That's what is written. Actually, that is the actual one used in mathematics. This is the actual one. Okay. But anyway, we'll use the finite version, okay, for our understanding. But it holds for infinite. And probably you would ask, okay, we are business school, why we care about infinity? The problem is, if your outcome is discrete number, roll a die, that's fine, right? But imagine you are finance or accounting, you deal with numbers, stock price, right? Or something that happened, right, in terms of money. Then the usual way we model this is a continuous variable. Later we'll talk about next topic, even infinite possibility, right? And that means that we really need to have some infinity at the background, although we didn't say it out, right? But money, right, is better modeled by infinity, and infinity things, you have to do calculus, and calculus you have a lot of things are unintuitive, right? So that's why you need this kind of stuff. But anyway, it's not our concern. So just let you know this, okay? And before we do it, just let me remind you several things here in terms of event. There's got intercept, union, and complement, right? Intercept is the idea of just n. Let me write that down again, because I guess that would be something that just to remind you, right? Intercept simply mean n in our context. Union just or, this is not. Okay. And this is the if you learn math or logic, right? This is a logic idea, and this is one logic extend to set theory. It's the same thing. Just the way people write. But if you want, you can just write and or not. It's the same thing. Okay. I mean, some people just do it interchangeably. Okay, I do it because this is the way the book used, so I just follow many books. So I don't want to be a very special guy to use something else, but this is the people use a standard way. Okay, but they're the same thing. Okay, because it's like E and L, which is the intersection, right? The common element there. Okay, and or we just take in everything there. Okay, and complement will be not, right? So you just cross out the thing. From sample say cross out 2, 4, 6, we get 1, 3, 5. That's all. Okay. And we have mutually exclusive. Just to say it again, it's like it can't be both true. That means mutually exclusive. Means one is true, the other must be false. Right? So if I tell you A and B are mutually exclusive, then if A is true, B is false. Right? So suppose in the jail or not in the jail is mutually exclusive, right? If you are in the jail, then it cannot be, it must be outside, right? Either one way or the other. So exhaustive, it tells you everything there, right? It's just like the union is the sample space, means one of them must be true. It rule out one thing, is like it can't be false, must be, it can't be both of them are false, must be one of them is true. It also allow both of them are true. Okay, and the last one is prediction, means a group of outcome or group event is prediction. It means at least one of them is true and only one of them is true. Okay, basically it's only one of them is true. Other are false, right? Cannot be both true. So only one of them is true. Now, I'm not going to go example again, but here is the several rules that we covered last time. This complement rule, I'm pretty sure you studied this in your high school, right? Because you calculate the probability there, because it's just like the idea of this diagram, right? You want to count how many things inside, but you can't count it. It's a lot. It's count outside. If you know the total, right? That's how you're doing that, right? Suppose the question is like the following. You learned it in the primary school or kindergarten, right? Suppose the farmer have 100 sheep, right? Then you ask how many sheep still in the farm. Suppose he lost 6, right? Then one way to do is go to the farm to count how many. But you know you don't need to do it. We just take 100 subtract 6, then you're done. Right? The same idea. Right? You don't actually need to go inside to see the detail. You know total, but probably must be 1. You just take away what's outside there. So it's just like that. That is the thing you learn in the kindergarten, right? The second one is also a kindergarten rule as well, right? You have 2 circles, right? You don't want to find, but they overlap, right? You want to find how to make that circle. You just subtract the overlapping area, right? Right. Suppose I'm doing a play doh, right? You make a circle, make a circle, right? And you calculate how much play doh you have to do it, right? Just take out the overlapping area, right? That is the idea, right? How much area you need to fill in order to do it, right? Just take the circle plus the other circle, take away the overlapping area, right? So A union B will be A plus B minus A intercept, right? So it, right? Just the short formula, right? This U is OR, right? A or B is equal to A plus B minus A and B, right? Just remember, if you don't really read that thing, you just remember you change to this is A or B is okay. A or B is just A plus B minus A or and B, right? Just remember that. Remember that, right? It's just like remember the graph, the kindergarten graph, right? The red, right? Plus blue, okay, and minus the pain, okay, will be equal to this guy. Hello? It's okay. Don't worry. There's so many scam telephone these days. Is I don't know why, but means many of them have been caught. So I hope they're okay. Yeah. So you can see, right? Red, blue minus this, and blue. Okay. I'm just joking for that one, so don't worry about it. I try to pretend I'm taking the telephone. It's okay. Don't worry about it. Is that okay? So that's the idea. You see, this is the idea, right? You have the red minus plus the blue minus the overlapping purple. This shape. Okay. And then this is the one we call total probability rule, which we will be using at the end of the Bayes theorem. We'll use it today. Is A, okay, can be decomposed in two parts. Is A with B and A with B complement. Okay. So we just the standard idea, right? Whether probably A will be A together with B and A without B, right? What is our future? Our future with you and future without you. That's something like that. Okay, the idea. Okay. So that's the idea, right? A, right, can be cut into two parts. This part is A with B, the middle part. The other part is the A without B, right? So that's why the idea why we do this is divide and conquer. It's like you always try to decompose things into small part, and each part can be easily calculated. Okay, because that's the idea, right? We need this rule, and later you see we need this rule to do what we want today. Okay. So this is saying that if you cut it into many small parts, the same idea. Because n different parts, it just B will be just B with A1, B with A2, B with A3, so on and so forth. Right. The graphically like this. I probably have to draw it back, maybe draw one because that would be useful, right? So for this, we can have a nice diagram. I don't know whether nice or not, but there will be a diagram, right? Partition means that, right? You would cut this into, say, this is A1, right? This is A2, say, and A3 and A4, just make 4, right? And B can be like this. This is B, right? And B can be decomposed into the red part, right? Red will be A1 intercept B, right? And you have blue part, right? This will be A2 intercept B, so on and so forth, right? You see B can be decomposed into this part, this part, this part, this part, right? So add up the same thing. Okay. Is that clear? The same idea here. Okay. I hope I convinced you this is the case. This is true. Okay. This axiom that actually we will need for the last theorem we learned from this class called Bayes theorem is actually one of the main things we learned from this class. Is how we should learn from new information. Okay. And this is one of the mechanisms that we talk about AI, right? AI is artificial intelligence, right? Why the intelligence is they can learn things very quick, right? That's why we are amazed at how ChatGPT or other AI doing it, because they learn very quick. And one way to learn is called the Bayes theorem. That is later we'll talk today. Okay? But before we do it, just finally, it's odd ratio. Okay, odd ratio is nothing but just restatement of probability, right? Probability is always range from 0 to 1, right? And odd ratio will be 0 to infinity, right? And say suppose the case is for sure is true, then probably A is 1, right? Right? And 1 over 0 is infinity, right? Right? So that means that if you try to draw a graph using your basic math knowledge, you will see if you try to draw a graph, the probability P is from 0 to 1, all right? And what's the odd ratio? We look like this, right? Okay. And you would know that if you math, right? If this is 1/2, this is somewhere 1, right? If probability A is 1/2, 1/2 over 1 minus 1/2 is 1, right? So if things are very likely, then you will expand quickly, right? And of course, you ask why we'll do this, right? Because in old days, I guess it's like people call about odd ratio because probably easy to calculate, right? Because equal likely thing is called 1, right? It's people talk about ratios. It's more easier to think, right? And this odd ratio is that okay? It's exactly related to the odd that we mentioned in our daily life when we talk about gambling, right? And odd or 4 to 1 means if you bet $1, you win, you get $4, you lose $1, right? And as we said, that is how you should understand is if the bet is fair, it is same as the inverse odd ratio. What by fair means that if you engage in this bet many times, if the bet is fair, you expect to break even, right? Like this example. Suppose what is favor of 6, right? If you roll a die fair, 1 6 will be 1, 1 6 will be, right? So that's 1/5. The odd is 1 to 5, and then you flip it is 5 to 1, which means the what? If you try to bet this, if the dice turn out to be 6, you win $5. If it's 1 2 3 4 5, you lose $1. Okay. In the long run, then you should break even. Why? Suppose you roll 6 million times. Okay. Out of 1 million times, you got 6. Right? So you would have 1 million times, you win each time you win $5, which means that you win $5 million. But for the number we have 1 2 3 4 5, each time you lose $1, then you lose $5 million. Right? So you win 5 million, lose 5 million on average, you're breaking even. So as long as the odd, right, is inverse of this, right, then you're breaking even. Okay. And why is it important? Because if you think the casino is fair, which usually is the case, it's not too much different from that. And actually that is reflecting that. And also maybe the casino that in Macau is different, but look at the casino in UK, but betting market, right? You can try to bet how likely tomorrow is there's a sunshine, what's the likely there's a typhoon, how likely there's hurricane, who is going to win the next election in the US. These are things can be bad. And if you think the market is efficient, enough people are joining, then the odd actually reflecting how people think about the future, right? So what I said is, from what the bet is, you can bet out probability from the market, right? That's how people think, how people calculate these days, right? Look at the interest rate difference. They can try to, now it has done, right? Because the Federal Reserve has decided the interest rate decision, but before it happened, the market movement, the differential of different things can actually guess what is going on there, right? And that's the idea, right? I'm not going to talk about this anymore, but that will be the idea why we care about the bet and odd, right? How do we relate to that? Okay. And now's the time to go a little bit deeper. We talk about conditional probability. Okay, that is actually related to information, right? Conditional means that we know something, how it changes probability. Okay, actually, it's the idea of data, right? You got a data, it tells us something. We learn something from the data. It changes our belief or change our perception of what might happen or may not happen, right? Because remember, probability at the beginning or idea is what we think, which one's more likely to happen or not, right? It quantify the ideas that we say this is more likely, it's less likely. Okay, so the idea now is we know something happened. So what do you think? Right? Okay, I think 3 weeks ago, we think now the famous KOL Lam Jok, I don't know whether you know, and then he get caught by police. But before this happened, people think he's very smart, very handsome, a lot of money, right? But now after this thing happened, I don't know how you think about him, but definitely different, right? So it's conditional. The statement is now you know B happened. Okay. How do you revise A? That's the idea. Okay. And the calculation is based on this formula, which I elaborate, but I hope you understand what are we talking about here is we know information of B, how we learn about A. Okay. To make this simple, consider the following. Okay. You roll a die. Okay. 1 up to 6. Okay. You try to guess the probability of say of 5. Okay. Now I tell you one thing. It is an even number. What do you think about the probability of getting 5? 0, right? Because I told you it's even number, right? If I tell you the number I got is large, means it's 4, 5, 6. What's probably getting 5? Okay, suppose the die is fair, it's 1/3, right? So now let's see why with this formula. First is A and B. Okay, it must be, you know, B has happened, right? So it must only relevant is A and B. Fair, right? Because you know B has happened, right? What happening outside B is no point, right? And the next is why to divide it by B, right? Because B is a new sample space. So you rescale it to make everything between 0 and 1. Okay. Still, this one looks like a little bit not easy. Let me draw a diagram. Maybe I should have put it in the slide as well. But remember the old put some graph like before. So this is A, right? And now we have B here. Okay, this is B. Okay, now I tell you B happened. Okay, so anything outside B is relevant. Okay, the question is I now know B, how likely is A happen? So it must be this area over the overall thing, right? So that is the idea, right? It's just this area, right? Over the overall thing, right? Is that clear? It's just this area as a numerator, right? Over this circle, right? Because this circle is B, this A and B, right? Is that clear? Because now this is must happen because B has happened, right? So it's just this, how big is this compared to how big is this guy, right? If they are not intercept, that's what I said, right? It's even number, right? There's A and B no intercept, there's 0, right? If it's large number, right? You have like 5 here and 4 and 6 is here. That's 1/3. Okay, don't worry, we give example, but that's the idea. Okay, just to remember the intuition, the numerator, right, will be because you know B happened, right? So it must be A and B only relevant, right? And denominator you divided by probability B is because probability is always between 0 to 1. So we just rescale it because only B had happened, right? No B had happened. So that's the idea. That's very simple. There's nothing new. Of course, you can prove it, but we're not going to prove it. But that's the same thing. Okay. I mean, actually, it can be proved. The proof is very involved, but we are not going to prove it. There's a basic proof in the slide as well. But if you want a more detailed proof, actually, you have to look at more statement. And this is non-trivial. I mean, non-trivial as 1 + 1, you need 2 pages of proof, but same idea. Okay. If you don't feel you're comfortable with that, just remember the formula. Okay. And if you really want to understand this, it's not easy. Just like to understand 1 + 1 = 2 is, I mean, you take a whole course to understand that. But if you go to the philosophy department, you have to take whole semester to understand why 1 + 1 = 2. Okay. Same as you go to stat department, the math class will tell you why this equation is true. I mean, they will spend whole semester understand probability and this. Maybe even more than 1 semester. But I mean, that is ideal. Okay, this is a formula. Okay. And this formula has been, I mean, we use it many years, so that's no problem. Okay. So I guess to understand this is that the best way to do it is to look at this example. After this example gives a break. Okay. But because it's so important, so let me finish this. Okay. So this is a roll a die once. You have 6 numbers, and I assume the die is fair, so make the case easy. And E is even number 2, 4, 6, large number 4, 5, 6, and E and L is 4 and 6. Okay. And now we know the outcome of dice is large, very similar to what I said. Okay, large is true. How likely that is even has occurred? Okay, just like I roll a die, I cover it, and then I tell you that okay, it's large. Then the question you're asking is how likely I have even number. Okay, and now the new sample space L, right? So what we have is just 4 and 6, right? Because there's no more 2, right? And that means that the sample L is a 3 object over 2 objects, so it's 2 over 3, right? You can do it directly. Okay, so this is the way that actually you can do it, because the new sample space is just only 3 items, right? You can just, one way to do it, just like you write the sample space, you knew the information, you remove everything that's not there, right? You can done. Or you don't have to do it. That's called the definition of, you can start from just the intercept over the total, right? That's the same thing. Is that clear how this being done? Right? So that's the formula. Is there any question? Okay. If no, then we have a 15 minutes break. We'll resume at 14:37. There's a break. So during the break, I would ask you to spend a few minutes to go to this one. This will serve as answer some question there, because that will serve as a attendance checking. We are not going to make it very strict, so that if say you miss one class, I take out 1 mark. No, but I try to see, because if you're not there for many class, then we have to ask what happened to you, because I think last semester that someone has some problem, doesn't appear, then there's some issue. So I just want to make sure everyone is here. If you happen to be, not there, then let me know. We don't want to worry about you. Okay, just you reply. And for this one, the break, we just ask very simple. There's no particular question we're asking, so don't worry. Just ask something You can just go on the phone and just log in and try to do. This one, the first one is just a very simple thing, so don't worry. So go to the website and try to log on. Oh, I don't know how to do QR code thing. I'll ask the PA to help me do QR code. Why there's no QR code? No idea. Sorry. But just type in this guy and you're done. I guess no QR code because you have to log in your stuff. I guess. Is it okay? Because it's after the COVID, then we really need to collect some attendance idea. So this first one, we just a very nonsense question. Try to see if you are able to answer them. Don't worry, it's not a quiz. Just doing something there. There's no right or wrong. Okay, there's something. Don't worry. Just to have some fun during the break. What? Yeah, just submit the file. Yeah. 應該 OK 啦，應該冇。Yeah, then done, right? Yeah, submit this file. Yeah, don't worry. You just submit and you're done. Don't worry. Right. Right. Yeah, but this is the event that is some of the result is the 36, yeah, yes. Yes. Why? Because 11 is 5 to 6 and 6 and 5. Only two outcomes. How to get 11 from two dies? The two of 36. Getting exactly 11 is 2 of 36. Exactly 12 is 1 over 36. Is it only? So, you will find because you just do the complement. You just calculate the 11 and 12, then 1 minus 11 and 12 and that. Yes. Yeah. Yeah, it's there's no mark from this one, okay? You do it, you're done. Maybe later we'll try to ask some question. Or sometimes I just no right or wrong, just try to see if you understand correctly, then we adjust our teaching. It's not something like there's no mark for that. Okay. You do it, you're done. It's just like do or not doing. And if you are absent from the class for quite some class, then we probably TA will contact you to see if you have some problem. Because you may need help, right? There's some issue, some people we need. I mean, before the COVID, we cannot contact you, but now we can contact you more.嗯，我唔緊要，唔緊要，你做我哋都係做例睇嘅嘛。可以，DA 都可以。你做 assignment，你做 assignment 知道我哋問你咩？我哋呢啲係教得會複雜少少嘅，但係就實際。 Good, my clothes is very simple. Any question you can ask me, or you can leave your message there. Right, I think that's some message. Or you can send me an email or send it to your email, or you can ask me now. Yeah, a question or comment, suggestion. Why are you coming for this class? 嚇咁難嘅嘢仲我講，覺得咁難同我哋呢啲咁簡單嘅嘢，用咪擺低先。 Yeah, I have a picture. After 2 weeks, one hour. They will do 1 hour. Not yeah, that is not problem. Maybe similar to the example. Okay. Maybe that similar to the example. People know. I don't know. There's no not very innovative. Not very innovative. Something you if you don't understand the example. Yeah, just like the test whether you understand the example. If you want to do more, there's always more example, more exercise. Textbook or I don't think I need to give you very hard. Just your assignment, just make sure that you try to read the notes again. But the read the question again, that's it. On the thing that need to apply. The idea is like topic one might asking you how to get the PDF all that. Then by hand and also by Excel. But Excel on topic two is discover the model. There's something very simple to go to spend more than that, then you have to work harder. Unfortunately. 3 more minutes. You will sleep. Then I stop this exam, and then let's see our result. I guess we can. Assessment. View. The end. And this. View. Okay. Everyone know what this data is good. I think in some case, I guess that some people don't know which day it is. I think that there's something like in China, in the exam, there's exam paper. The first question is to put the photo of 4 people, one of them instructor of the class, and people fail to recognize who is the instructor. Maybe I should try this, right? Know whether you actually in the class. Okay. The second one, yeah. Okay. Oh, that's interesting because even for this, people have different view, whether it's a cloudy or sunny. And what do we cover? Okay. So I like this statement. Probably it's very hard. Yeah, I completely agree. I entirely agree because some of you may know my undergrad is IFAA, right, which actuarial science. So that's basically I spent 3 years. That was a 3-year program at that time. I spent 3 years doing probability. I still think it's very hard. So even I teach this class, I still think probably something is a mystery to me. There's so many things can be learned. Yeah, that 3 axiom. So everyone. Yeah, I like this statement. The possibility of taking the UV price 1/4. Yeah, try to view many formula. No need to remember a formula. Let me emphasize your test is open book. You can bring as many papers as you want. No need to memorize. And there's no point to memorize because now AI is there, right? So you just need to know where to get the thing and get the intuition. That's why I talk about the conditional formula. I tell about why this is true, right? Because the formula is always there. And if you really want to do calculation, it's already computer do it. So understand why it's true is important. Okay. And so there's some people I'm okay. I think it's the right speed now. Okay, that's good. I think it's good to have this because I get to know how you're thinking about the course, and then do email me if you think I'm going too fast or too slow. Okay. And of course, for QFN student, it must be very slow, but I just ignore that comment. Okay. If someone from QFN say I'm too slow, yes, it's too slow. If fast, then take the stat class. Okay. I mean, because this is for the general average audience. So next is this example. Okay, during the break, some actually asked me how you remember this formula. Just conditional on B, the denominator is B. That's it. That's how I remember. Okay, but as I said, now we have computer. There's no need to remember. This is what just whenever you need it, just Wikipedia it or look at the slide and you're done, right? Just because no need to remember this. Okay, but what you need to remember is why is it true. Okay, why it's true is very important. Okay, and let's go. This is an example, right? As I written already, right? 5, 6, 7, right? 4, 5, 6, right? And large is 4 and 6, right? It's 2/3, right? Because the sample space shrink. Okay, so that's why you divide because you make everything inside 1, right? Because this follows from axiom 2. Okay. Now this is some of you asked me the assignment question. It'll be something like this, right? Same as this. You see similar question assignment, but with different numbers. So because it's hard for you to know whether you understand the example, so I just modify some of the example, right? So it shouldn't take a long time for you to do the assignment because it will be some variation of the, right? So to this example, just some numbers, just plug in. Okay. I don't think I need explanation for that, right? But you can see I have a probably A, I give this to try to trick you. Okay, actually it's not needed, right? But is that okay? Okay, I don't think I need to talk too much about this one because it's so straightforward, right? If there's still question, ask me or TA. Okay, I just skip. Okay. So this one is nothing new. But this is one way you can calculate the intercept. Okay, the n. Okay. Probably A and B is probably A given B times B or B given A times A. How do you get that? That is actually direct from what we have just learned. Go back to this. Okay. As long as this is not zero, multiply this both sides. That is what we have. There's nothing new there, right? There's nothing new, right? But why we call this a multiplication rule is because this is very useful and we use it all the time. Because to calculate this, you can decompose it in two parts. And this from this is very simple, right? Just call A B, B call A, right? Just that. Is that okay? You call A B and B and A the same thing, right? The same thing. Okay. I guess this would be best to be illustrated by the standard thing you learn probability. Okay, you draw something from an urn, okay, and you do it without replacement. Okay, so what the question is, you have an urn with a boat, which you have 3 white balls and 3 black balls. Okay, and you try to draw 2 balls from there. Okay, and without replacement means you take out the ball, you don't put it back. Okay, you can imagine I take out 2 balls, right, sequentially, one by one, or same time, doesn't really matter anyway. So the question is, how likely you draw 2 balls are black? Okay, I guess this is very classical idea, right? And many of you are actually from accounting, right? This is the question, right? You go to a warehouse, right? And you want to try to see how likely, suppose you know how many things are defective, right? Then you would try to say, right? Suppose black are the best thing, right? Suppose you go to a warehouse, okay? The client claim half of the goods are destroyed or damaged, and half of them is good, or half of them bad, right? Then the question is, okay, suppose that's the case, I try to draw 2 samples from the warehouse, right? And turn out that 2 of them are the black thing or the broken one, right? Then you want to see what's the probability of this. Is it big or small? If it's small, then you will try to infer the client is not telling the truth. That is the ideal hypothesis testing, right? Assume what the client says true. You try to see something from there. If this were unlikely, then you will try to say the client is. I cannot assert what client have been said, right? So that's the idea. But we don't talk about whether this thing to do judgment, but we just say, assume client said it's right, what's the probability of doing this and that, okay? Whether you make a decision is will be something we will talk about in the topic 6, okay? Hypothesis testing, those kind of ideas. But this is build the foundation, right? And this is something you do, right? I mean, you go to a warehouse, you try to check, right? And according to the client, what they said, then you go to check. So this is very standard, right? And you do sample without replacement, right? You take out one thing and take other thing there, right? You know, you will not put back, right? Right? Fair, right? You understand why we're doing that, right? It's very intuitive and applied to accounting from auditing. So the question would be like the following, right? So we define B1 is the first ball is black, B2 is second ball is black, okay? And the probability the first ball is black, suppose you randomly draw it, is 3 over 6, right? Because we have 6 balls, 3 of them is black, right? And the question would be, B2 is very difficult to calculate, right? Because B2 it depends on what happened, right? Because you draw depends on if the first one is black and first one is white different, right? If first one is black, maybe I draw it because that would be easier for you to understand, right? So suppose I have this. Okay, I have black, 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 right? And then I have white, 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 right? You can't see the white. White, white. Is that okay? Is it better? Okay. So 3 black and 3 white. Okay. So the question, you have 3 white here and 3 black. The first one is 1 over 3 over 6, right? And now, after you draw 1 black, what does that mean? It means that the following, right? You no longer has this one. Suppose this is the first one you draw, right? So you only have 5 ball left, right? And you are talking about randomly draw 1 ball. The probability of the black will be 2 over 5, 2/5. That's how you get this one. Is that clear? So how can we calculate the probability both of them black? Will be just multiply together. That's what you said the multiplication rule. Is that clear? So that is how you'll be doing. Okay, 1/5 time you will draw. Okay, and if you happen to be 2 black, then probably you could think about how likely you would have this, right? So you can change number, your 3 ball and 3 white ball, you can change number, then you can see the probability how it changes, right? And then as I said, right, there's a judgment can be made, because assume this is what the client tells you. You can see if this thing happened, then you can judge, right? But that will be, we're not talking about those in this class. Yes, please. Oh, yeah, you can calculate that. Yeah. So the question would be, what is the probability that the first is white, the second is black? Okay, good. So let's do that. It's a very good question. So the question being asked is, let me write that down. What's probability that we have a white first and black second, right? So then we calculate probability of white. First one is white, is 3 over 6. I think you agree. And how do you do this guy? Now, after you draw a white, how many black you still have? You have 3 black and 2 white. Am I right? So the probability black will be 3 over 5. So then you multiply of, then probability of, the question is, you want to calculate and W1, right, will be 3 over 5 times 0 over 6, right, would be 9 over. Okay. Oh, sorry. Yeah, I don't qualify to graduate from the primary school. 30, right? So here, do note that I have, the tricky thing is, okay, you asked a great question, because this is you have drawn the white and black, right? But it can be black and white, then actually double, right? Because symmetric. So that's why if the question asks black and white, or I don't care the order, that's different. If I don't care the order, it will be 18 over 30. If I have black then white, then it will be 9 over 30. It depends on how what is important, right? If I close my eye and draw 2 things, then will be have to be 18 over 30. If I open my eye, I ask what the first time is black, the second time, so first time is white, second time is black, then will be different. Okay, have to be very, very careful. What are you saying? Is that clear? The same depend on whether you count the 2 things are different, right? Because if 2 black, the same thing, because same thing, but this will be slightly different. Black and white will be different, right? Because you distinguish right and bad and white, depending on whether you distinguish. Okay, that one had, I mean, you're right, you have to be very careful how we define things. Okay. But don't worry, I mean, we are not stat class, so we don't try to trick you making this kind of statement. But if you go to stat for QFN student, right, that will be important, right? Because stock price go down and go up is different from go up and go down, even though they go back to the same place. If you look at the binomial trees, binomial trees, and talk about the auction pricing, there will be something different. But I mean, there will be a lot of things there. But we are not that class, so I mean, there is something there, but we are not going. You don't need to worry about this technical detail. But I want to let you know there's some technical detail here. But my intention not to ask this kind of question. Okay? I mean, I definitely would ask some question related to that, but I will not try to trick you into this kind of problem. But the complication, I mean, as you can see, okay, depend on whether you count the order or not. Okay. Because it really depends on how you define the sample space. That's a question. Okay. But anyway, I guess currently we don't have to worry about that. Okay. So this is usually we call the tree diagram. And this is the usual way people represent this kind of problem. Okay. You have 3 white and 3 black. Half of the time you will draw a black ball, half of the time you draw a white ball. Okay. And depend on you draw the second time is black or white or black or white. So actually this is what we will just ask, right? And white and black is here, black and white here. So it depends on whether you care about the order. If not care, then you add up. If you care, then you separate, right? Because you have to tell me the definition of event, right? The event is the 2 balls are either black or white, right? You say the first ball is black, second ball is white, right? So that's why whether you consider this separately or jointly, okay? Is that okay? So you would multiply along the tree to get the answer, right? This is the multiplication rule here, right? At the end, this is the end outcome, right? It's this and this, right? And actually the multiplication rule will tell you, right? You can just multiply along the branches to get the final answer, okay? Let me repeat the statement. Why do we learn the multiplication rule? To justify why we can multiply along the branches, right? You keep multiplying, okay? Because these are the conditional probability, right? Conditional on this, you have this probability, right? This is say this number, right, is conditional on first one is W1, second W2, right? So these are conditional probability. You can multiply along, right? And the tree can go on and go on, or you just keep multiplying. Is that clear why we need multiplication rule and how we relate it to the tree? Okay. And usually this is what you see, but that's there. I mean, that is easy to understand what's going on because later we'll talk about base rule. That would be the thing. Okay. So here is the rule. There's nothing new, but just combining 2 rules, right? The first line is total probability rule, right? I guess we have talked about that last class. The second rule is just use the multiplication rule, right? You just make it into this way, right? Make it this way. So there's nothing new. There's no new rule here. Okay. Why we need that will be immediately clear. Okay. This is what we call the total probability rule plus the multiplication rule. So this rule we'll use it now. So this is the rule that make the calculation easier. Remember, this is called divide and conquer, as I said, right? Divide and conquer. So the idea is following. Okay. Also, where standard thing is you're not drawing from 2 urns. Okay. You have 1 urn, 1 bed, have 4 whites and 1 green. Okay. And the other bed is 1 white and 1 green. Okay. And the question is, you're going to choose a bed, A or B. Okay. You just close your eye, randomly choose a bed. And then once you choose a bed, then you choose and ball from the bed. Okay, it's two-step process. First, choose one of the two bed between A and B. And once you choose the bed, then you draw a ball from there. The question is asking the probability of the white ball. Okay, and remember, this is same as what you imagine what you do in the you will do it in the warehouse, right? You go to the site, the warehouse or the factory, there are multiple production line or multiple shelves, right? And the shelf likely to be heterogeneous, right? They will tell you maybe the shelf here is near to the exit or the entry likely to damage, or there's some structure there. Or production line, they will tell you this line tends to be better than another line. This is a new machine, the old machine, right? There are more defective item from this machine than the other, right? So on and so forth, right? The different thing. Okay. So the question will be, you get a whiteboard, then you try to see whether the guy tells you the truth or not, right? But that before you can do that, you have to calculate how likely the whiteboard, right? So how do you do that? Whiteboard actually can come from two things, either from A and B, right? Depending on whether bed you draw is A and B, and they're mutually exclusive, right? Whiteboard can come from bed A, and whiteboard can come from bed B, right? And they're mutually exclusive, so that's why. And also the exhaustive, right? Because you must draw from one. Basically, it's partition, right? So that's why you can do that. Remember, you can do it because it's partition, right? A's complement is B, B complement is A. See that, right? And then from here, you will do a conditional statement, the multiplication rule. W and A is W given A times A. W and B is W given B times B. Right? And then how likely to get A and B? Just one half and one half. Right? Because you close your eye and open it. Right? And the question would be, what is this two guy, right? Because these two guys we know is very easy to calculate, right? But that's not difficult, right? If you're A, how many balls do you have? 5, out of which 4 is white, so 4 over 5. And B, you have 1 white and 1 green, right? So there's 1 half, right? Just add up. So it's 0.65. Is that clear how we do that? Okay. And this is also a very classical problem, right? And I explained it's often in statistics and also often use it when you go to audit in the warehouse, right? And this also happened in finance, right? Imagine A and B are, A is a bull market, right? And B is bear market. White can be considered as the stock market goes up, right? It's more likely to go up, right? In the bear market, maybe equally likely to go up and go down, right? Then you can calculate how likely the stock price goes up, right? So everything actually can be faced in a very nice framework, right? Okay, is that clear? Right, so that is a okay. Any questions? Because I mean, when I learned this, I found it very difficult. Okay, maybe you guys are very good now. So anyway, different from my time. I guess because anyway, whatever. So this is the tree diagram. Okay, this is telling you probability you go A and B, right? And conditional on B, whether you get white or green, same before, right? And then you can multiply to get using the multiplication rule to get everything there, right? And then to get white is actually this guy and this guy, right? Because only these two have white. So we just add the first and the third branches and you're done. Okay. And depending whether you are a person who like to look at graph or do the math, doesn't really matter. We end up the same answer. Is that clear? I mean, as far as for me, I would like the graph. But if you are a mathy person, then formula is more concrete. Is that clear? I mean, just to make sure that you understand what I'm saying. Just if you are a person who like to draw graph, then just add up these two numbers, right? Because only these two relate to white, right? Because the other two are green. The add this number, right? It's up to you. What do you think is easiest? Okay. Because all these outcomes are mutually exclusive, right? So just add up these 5. Okay, good. Now we talk about some definition, then we'll talk about the important theorem called Bayes rule. Okay. So here we talk about whether things are independent or not. Okay. If it's independent, it's very simple, the idea. Telling you B has happened, can't help it. That have no change, right? Learning the information on B has no impact on A. Okay. Or learning A has no impact on B. Or the join is just multiply of them. Okay. And I don't prove it, but these three are the equivalent. Okay. You can do one way or the other, doesn't make a difference. Okay. I mean, whatever, the three will be the same. Okay. You can prove it, but we're not math class, so but the proof is already in the. I don't have the proof, but easy to prove. Okay. So the question will be like this, right? You have. I give you the numbers. I ask you whether independent. You can just multiply and see whether the multiplication equal to the n. If yes, yes. If no, no. Simple. Okay. So I'm not going to talk about those. I skip the technical part because I don't think you will need it for our purpose. So let's go to the important one. If you want to ask the answer, but maybe I should talk one thing is like, maybe it's good to talk about this. Mutually exclusive actually means they're not independent, right? Because I tell you A had happened, B cannot happen, right? So that's why time say you mutually exclusive is exactly opposite of independence, right? And that's what I'm doing here, trying to tell you, and also independence on sampling without replacement. Okay, sampling without sampling with replacement means independent, right? If I earn, you draw a ball there, you put it back and draw again. Each drawn is independent, right? Regardless of what you drawn, the first one put it back, draw again, same thing. So that is exactly the example independence. Okay, this is what these two slides means. I guess, right? If you don't put it back, they're dependent, right? So that's what I'm saying. So I guess actually I did cover the technical part, right? So it's okay. I didn't skip any slide. So last one, as I said, is the most important thing. This is what we call learning, and that is what one of the way if you do machine learning or artificial intelligence, this is the way, one way they learn it. Okay? This classical way, how we learn it. Okay. And what we want is now I have what we call initial belief or prior, what we think that is right at the beginning is PA. Okay. What we learn from the past or history, from theory, whatever, from data. And now we know tell you B has happened. Okay. And how would you think about this? How likely A has actually happened? Okay. So that's what the audit thing, right? Auditor, right? Just keep updating your auditing evidence. B, then you update A. Okay. And the Bayes rule said the following, which is actually the name is very big, but that's nothing. But remember, this is just a multiplication rule. This is A and B, right? But this is A and B, right? This rule looks, the name looks very great, looks very intimidating, but this is nothing, right? But this guy, because it's A and B, right? We write they're equal because this is called the multiplication rule, right? But why this is so important? The important part comes from the following. Do you note that here we have B given A, and here A given B. So we're able to swap. Okay. As long as we know how A and B are related, we can swap the thing. Okay. So probably later you will see why we need this formula. But this is the formula. It's not difficult to derive. And usually I don't remember this formula. Usually I would just remember this definition and then apply multiplication rule. That's how I remember. I never remember this, but if you really want to remember, you can remember. Okay. But I never try to do it. But if you do it, do it. Okay, that's fine. Some people are very smart. But I'm not, so I just do it. I just don't memorize it. I just start from this one and conditional probability, and that's it. Okay. And probably you want to know why we need this formula. As I said, this is the single most important formula from this topic too. Okay, why this is important? Is that okay? Okay, this formula is nothing new, right? There's nothing particular difficult here, right? Just apply the formula we define. So usually that's called the prior, and this is called the likely over marginal. So that is the terminology. People call this posterior. This is called prior. Okay. And A, they call it likelihood, and B is marginal. Okay. And why this lie? Because this is something, if you don't read math textbook, you try to read medical or science or engineering, the terminology they use. Okay. Not sure whether they want to do it, but this is how they do it. Okay? Especially with the medical literature, they have a very special term. I mean, try to make sure that you know what you're doing, but it's not important for our purpose. Okay. And here is trying to say that a lot of time people would ignore the denominator. So this is proportional to the numerator part, right? And that's why posterior is likelihood times prior proportion. But I put that there because not because it's important, but because of some people mention this name. You need to know what's likelihood and prior. I mean, but for our class, we don't use this terminology. Okay, so that's why I'm not going to talk about those, because we don't use it. I just put it there because when you read other people's, when you try to read some daily article, they would use that. Okay, I'm not using it from this class. Okay. So this is a proof. I mean, I don't need to prove it, right? We know it. So I think we can go to why this is true. Okay. And now the question would be, you want to know the probability B given A, right? The formula, right? Then what we're going to do is look at the denominator, right? Probably B is like here, right? And given A will be this one, okay? So this will be black, sorry. No, this one is just this branch over this. Okay, let me show you the example, then you see. Sorry, I think the color is not correct. I mean, the English is right, but the color is wrong. But anyway, let's see this example. This example is the most important one. Okay, after this, I think we'll end for today. Okay, this is the only example. We have a two bed. Okay, A and B, 4 whites and 1 green, and 1 white and 1 green, same as what we have before. Nothing new here. Again, the same thing. Close your eye, choose a bed, and choose a bed, and close your eye and draw a ball. Okay, standard. So now we reverse the idea. Okay, before we just ask you what is the probability in white. Now we ask the question: if I get a white, is it come from A or come from B? Which one more likely? Okay, even without any idea, what do you think? You might think A is more likely, right? But I spoiler alert. Now later we see. Anyway, let's do the calculation. Okay. So you would think that but I'm guessing, right? If you get an A, you get a white, which is 4/5, right? If you're B, that's 1/4. You would think A is more likely, right? Then let's see whether this case. Remember, it's equally chosen. A and B are equal to 1/2. Now apply the formula. Okay, we want to figure out this: Y given A and Y given B. Right? So just if you don't remember, so let's remember the formula here. Let's do that. The formula, if you can check it out. If white, right? Remember, I never remember the formula. So what I do is A and white, right? That's what I'm going to do. But what I'm going to do is I will just decompose it using the multiplication rule, because we know this. We just found, right? Is that clear? Is that clear what I'm doing? So this is just applying the base theorem. Right? If you really very mathematician, right, then we just apply the formula directly, right? But if you're not, then just apply what the conditional probability and then just apply that, right? This guy you know is 1/2. This guy we know is 4/5. What's left is denominator. Is that clear what we are doing? Why we're doing the first step here? Because we want to know the denominator. Okay. The denominator is using the total probability rule, as I said, right? Will be white, will be actually it's like this, right? White under A or white under B, right? And this is what we have calculated in the previous example, right? Probably white. So this is nothing new there. We calculate that. So we know this guy, know that we're done. Actually, we know. Okay. Don't worry, we will go over this example again next class again, because I think that's important, right? So now we have this formula and here, right? By construction, you know it's more likely from A, right? Because white is more likely from A, right? So you got a white is most likely from you have drawn A. Is that clear? So this is just to quantify our belief, right? Because A has more white, you got a white is more likely from A. Okay, but we will talk about this again next week, since we haven't finished. So I will not release the assignment until we are done. So probably next week we will release the assignment. Anyway, our assignment will be you always given at least 2 weeks to finish before the deadline. So don't worry about that. Okay. So I'll see you next week.